In this lesson, you will learn to find the greatest common factor and the least common multiple of both integers and monomials. Now, when we say prime factorization, we need to know what the term prime means and then what the term factor means. So the term prime is contrasted with the term composite. And you may have learned this before, but to review, in case you forget, prime are numbers that are greater than 1 and whose only two whole number factors are 1 and itself. So for example, we see here there's a list of numbers. And if you look at each number, the only number that we can divide each of these by, any whole number, would be itself and 1. So for example, the number 3. We take 3. The only thing we can divide 3 by would be 1 or itself. There's no whole number that we can divide the 3 by. Same thing with a 2. Same thing with a 5, 7, 11. There's nothing to divide each of those numbers by that would give you a whole number back out. Right? If we took 11 and tried to divide that by a 2, we would not get a whole number. We would get 5.5. Right? If we divide by 3, once again, we're not getting a whole number. It's not dividing evenly. We cannot divide 11 or any of these numbers by anything without getting some sort of fraction, because they will not divide evenly. That's in contrast to composite numbers. Composite numbers are whole numbers that are not prime. So for example, I guess that'd be any other number that was not listed up here with the prime number list. And if we look at each of these, let's take a look at 4, for example. We can divide 4 by some number other than 1 and itself. In this case, we can divide by a 2. 4 divided by 2 would give me a whole number answer back out. If we take 6 and divide it by 2, we would get 3. We can take 6 divided by 3 and get 2. Each of these numbers, 9, 12, 10, we can divide by some number and get a whole number back out. So those would be composite. So that is what prime and composite mean. So when we try to find the prime factors of something, we're trying to find numbers that are prime, so only divisible by 1 and itself. And then a factor means something that you can divide by evenly to get a whole number back out. So for example, if we were told to find the prime factorization of 400, what we are doing is we're trying to break up the number 400 into numbers multiplied together, and eventually we want them all to be prime numbers multiplied together to get to 400. So for example, if we take 400, we can think of that as 2 times 200. So we broke 400 apart to get 2 times 200. 2 is a prime number. We cannot divide 2 by anything else other than 1 and itself. So the 2 is part of our answer, but the 200 is still not prime. We can still divide 200 by something. So let's break apart the 200. The 200 we can break apart as a product of 2 times 100. So we carry the 2 down. The 200 would be 2 times 100. So now we have 2 2's, which are both prime numbers, and we have 100, which is still not prime yet. So then we break apart 100 again, and we can think of that as 2 times 50. So we carry down this 2, we carry down this 2, then this 100 we break apart as 2 times the 50. So now we have 3 2's that are all prime, but we still have this 50 that is not prime yet. We can still divide this by other numbers. So the 50 we can break apart again to get 2 times 25. So we carry down these other 2's, and then 50 would give me a 2 times 25. So now we have 4 2's that are all prime multiplied together, and 25 is still not prime yet. Because 25 we can divide again, and we can divide this by 5. So we can write 25 as a product of 5 times 5. then we bring down all these other numbers. Now notice we have 4 2's and 2 5's multiplied together, which would give me 400. And each of these numbers down here are all prime. We cannot break them up any further. So this here is my solution. This is how you prime factor the 400. We have found all the prime factors of 400. So that is what we're trying to do. And the reason for doing this will be explained in a moment in the lesson, where we can use this to find what we call the greatest common factor and the least common multiple. And as we move through the lesson, we will get more practice with finding the prime factors as we go. So beginning with the greatest common factor. What is the greatest common factor? Well, it is simply the greatest integer or number that is a factor of each. So for example, here we have the numbers 8 and 12. And we are wondering, what is the greatest common factor? Which factor is the biggest one that they have in common? Or another way to think of it would be, what is the biggest number that divides evenly into both 8 and 12? Well, we think they're both even. We can divide both by 2. 8 divided by 2 gives me a 4. 12 divided by 2 gives me a 6. Okay? But is there a number that's bigger than 2 that divides evenly into both the 8 and the 12? Well, yes. A 4 would be bigger than 2 and can be divided evenly into the 8 and the 12. 8 divided by 4 works, gives me 2. 12 divided by 4 also works, and that gives me a 3. So the greatest common factor would be a 4. That is the biggest number that divides evenly into both 8 and 12. So the GCF, or greatest common factor, would be 4. Now the question is, how do you find that? So yes, we want to know how this works intuitively, but in case you have big numbers, and later we're going to use letters, we're going to use variables, we need to know what is the thought process so that we can find the GCF for anything, instead of just trying to think through every possible scenario. So what we want to do is we want to break apart both the 8 and the 12. We want to find the factors of each, the prime factors of each. So we start there. We find the prime factors of both 8 and the 12. So the 8, we can think of 8 as a product of 2 times 4. We can break it apart to become a 2 times a 4. Now the 2 is prime, the 4 is not. So the 4 we can break apart again to be a product of 2 times 2. And then we carry down this 2 right there. So we can think of 8 as a product of 2 times 2 times 2. Okay? And the 12, same thing. We're going to break it apart, and 12 we can break apart as a product of 2 times 6. So the 2 is prime, the 6 still is not prime. So the 6 we can break apart again as a product of 2 times 3. So now we have 2 times 2 times 3 for the number 12. So that is where you want to begin. You want to find the prime factors of both set of numbers. Okay, so then from here, what do we do? Well, we want to find what factors they have in common. So for the greatest common factor, we're asking or looking to see what factors do they have in common. So we look down here at this bottom row, okay, and we see what factors do they have in common. Well, they both have a 2 in common, and they have another 2 in common. So they have 2 2's in common, so my greatest common factor is a product of those 2 2's. So the 2 times 2, which would give me a 4. So that is all we do to find the greatest common factor. We prime factor, and then we see what factors do they have in common, and then multiply those together. All right, let's try another example. Here we have 24 and 12. So going through that process, we can find the GCF, or the greatest common factor. So the 24, you can break 24 apart to be a product of 2 times 12. 12 can break apart to be 2 times 6. And the 6 can break apart to be a 2 times 3. So I prime factored to get 2 times 2 times 2 times 3 equaling 24. And the 12, same thing. 12 is 2 times 6. 6, you can break that apart further to get 2 times 3. So to find the greatest common factor, we see what factors do they have in common. Well, they both have a 2 in common. They have another 2 in common. And they both have a 3 in common. So my solution, my greatest common factor, is a product of each of those common factors. So 2 times 2 times 3, which would give me 12. So my GCF would be 12. And you can just think through this intuitively if you want as well, but do get used to the process so that way it will carry you through the more difficult questions. But yes, we can see, okay, intuitively that 12 is the biggest number that you can divide both 24 and 12 by. Because 24 divided by 12 is 2, 12 divided by 12 is 1. They both divide evenly with the 12. So we can think through it intuitively, but do get into the practice of solving this way. Now here we have three numbers, okay? 24, 12, and 30. Well, at 24 and 12, we've already broken apart, and we've got these prime factors. 30, we can break that apart, and we'd get 2 times 15, and 15 can break apart to become 3 times 5. So if you have three numbers you're trying to find the GCF for, we still do the same thing, but just make sure that our factors are common with all three set of numbers. So which factors do all three have in common? Well, there's a 2 that they all have in common, and then there's a 3 that they all have in common. So my greatest common factor of all three of these would be 2 times 3, which would be 6. And which makes sense. We can divide 24 by 6 to get a whole number, to get 4. 12 divided by 6 divides evenly. 30 divided by 6 also divides evenly. And so this would be your solution. Now to find the least common multiple. This is a similar setup, but a little different at the end. And what it is it is the least positive integer having each as a factor. So for example, if we look at 8 and 12, the multiples of 8 would be 8, 16, 24, 32. If we take 8 times 1, we get the first number. 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, and etc. Those are multiples of 8 because I'm multiplying 8 by a number. 8 times 1, 8 times 2, 8 times 3, 8 times 4, and etc. Multiples of 12 would be 12 times 1, or 12, 12 times 2, 12 times 3, and etc. So those are multiples, but the question is to find the least common multiple. So what is the smallest multiple that they have in common? Well, looking at the numbers 8 and 12, the answer would be 24. That is the smallest multiple that they both have in common. So my LCM would be 24. So I can think through intuitively for some of these questions, but I do want to show you, and I do want you to get used to the process to finding the least common multiple in case you have more difficult numbers and also when we start throwing in variables. So using this example, 24 and 12, trying to find the least common multiple, what I do is I first want to begin by breaking each of these numbers apart. So finding the prime factors of 24 and 12. Well, 24 you can write as 2 times 12. The 12 can break apart to be 2 times 6, and the 6 can break apart to be 2 times 3. Okay? And then the 12 can break apart to be 2 times 6. 6 can break down to be 2 times 3. So to find the least common multiple, I begin here, just like with finding the greatest common factor. The only thing that's different is this last part. So to find the least common multiple, what I'm doing is I'm going to see which factors do we have represented. Well, we see we have 2's and we have 3's. So we have 2's and we have 3's. So that is going to be somewhere in the least common multiple final solution. But the question is, how many 2's and how many 3's do we take? So what we do is we look at each set and see which set has the most 2's and which one has the most 3's. Well, over here, the 24 has the most 2's. It's got 3 of them. So we take the one with the most, which is the 3 2's. So now we have 2 times 2 times 2. And then we look at the 3's. Which one has the most 3's? Well, this one's a tie. They both have the same number, so it doesn't matter which one that I take. But we'll just take one of them because it's a tie. So we have 1 3. So we multiply those together to get my solution of 24. And that's it. Let's try another one. Here we have 8 and 12. 8 can break down to be 2 times 4. The 4 can break down to be 2 times 2. The 12 can break down to be 2 times 6. The 6 can break down to be 2 times 3. So to find the least common multiple, we see which factors are represented. So we have 2's and 3's. So 2's and 3's. And the question is, which one has the most? Well, over here, the 8 has the most with 3 2's. So we take all 3 of its 2's. So 2 times 2 times 2. And then which one has the most 3's? Well, the 12 has the most 3's with just one of them, so we take 1 3. Then you just multiply those together, and you're going to get 24. And that is my least common multiple. And intuitively, we can probably conclude that as well, because if we think of the multiples of 8, we have 8, and then 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, etc. Then for 12, 12 times 1 is 12, 12 times 2 is 24, times 3 is 36, and etc. Notice they both have a 24 in common, so that would be the LCM, or least common multiple. Now we have 3 numbers represented, and we want to find the LCM of all 3 of these. So still the same concept, where the 8 can break down to be 3 2's, the 12 you have 2 2's and a 3, and the 15 can break down to be 3 times 5. Now to find the least common multiple of all 3 of these, same exact concept, where I see which factors do we have represented. Well, we see there's 2's, there's a 3, and there's 5's. So we have 2's, 3's, and 5's. And the question is, how many of each do we take? Well, see which one has the most. So here we have 3 2's. This one has the most 2's. So we take all 3 of its 2's. Okay, which one has the most 3's? Well, it's a tie, so it doesn't matter which one we take. So we'll just take 1, however, because it's a tie of 1. And then which one has the most 5's? Well, there's only 1 5 over here. The other ones do not have any 5's. So take the one with the most, which is just 1. So we just have 1 5. Then you multiply those together, and you get 120 as your solution. So 120 would be your LCM. Now if you had monomials, so now we're going to expand this to not just numbers, but then also now throwing in variables. It's still going to be the exact same concept. So for example, here we have a squared b cubed and a to the 4th b to the 4th power. And the question is to find the GCF of those 2 monomials. So for the greatest common factor, the GCF, we see what factors do they have in common. Well, it may be helpful to write this out all the way. You don't have to, but I will show this for the first example to kind of visualize what we're doing. A squared is the same thing as a times a. B to the 3rd is the same thing as b times b times b. Okay? And then the other one is a to the 4th, so we have 4 a's. And then we have b to the 4th, so we have 4 b's. Okay? And then from here, for the GCF, we see what factors do they have in common. Well, they both have 2 a's in common, and then they both have 3 b's in common. So that is what they have in common, and put that together, we have 2 a's in common, so a times a, or a squared, and then 3 b's in common, so b times b, or b cubed. So the GCF would be a squared b cubed. You don't need to write it out like that, but it's maybe helpful to see what we're doing. But as long as we get the correct solution, we're good to go. And then for the LCM, least common multiple, we're doing the same process we did with numbers, where we see what factors do we have represented. Well, we have A's and we have B's. So we have A's and we have B's. And the question is, how many of each do we take? So we're going to ask ourselves, which one has the most? Well, the most A's would be over here. We have the most A's with 4 of them. So we take 4 A's. And for the B's, which one has the most? Well, over here has the most with 4 B's. So we take all of those B's. Put it together, a to the 4th times b to the 4th gives you just simply a to the 4th, b to the 4th. And that is my solution. Here's another example where now we have 3 monomials, and we're trying to find the greatest common factor of all 3 of these. So what factors do they have in common? Well, notice this one has 2 A's, this one has 4 A's, this one has 1 A. What do they have in common? Well, they all have 1 A in common. So we take 1 A. And then do the same thing with the B's. This one has 3 B's, here's 4 B's, and here's 6 B's. What do they have in common? Well, they all have 3 B's in common. So we take 3 B's. And then as far as the C's go, there's only 1 C here, and it's not in common with any of the other monomials. So there's no C's as part of my GCF for this example. So my solution would simply be A times b to the 3rd power. And if you want, you could write out, like I said, A times B times B times B, but that's going to be tedious and not necessary. But if it's helpful, you can do it that way. So the LCM of this same example, we do the same thought process we use for LCMs with numbers, and we see which factors do we have represented. Well, we have A's, we have some B's, and we have some C's. And the question is, how many of each do we take? Well, we take whichever one has the most. So for the A's, for example, we see right here, this one has the most with 4 A's. So we take all 4 of the A's. Which one has the most B's? Well, this one has the most B's, so we take all 6 of the B's. And the C's, which one has the most of C's? And that's going to be right here. This one has 1 C, so we just take the 1 C. We put it all together, and we get our solution of a to the 4th, b to the 6th times c. Next, I would like to explain how to find the greatest common factor and the least common multiple of expressions that include both numbers as well as variables with exponents. So here we see now we have a 12 along with the x squared y to the 3rd and the number 30 with x cubed y to the 5th. So what I want to do is look at the number part separate, and then we'll do the variables at the end. So looking at the 12 and the 30, I need to find the prime factors of both of those numbers. So the 12 can break down as a product of 2 times 6. The 6 can break down as a product of 2 times 3. So now we have 2 times 2 times 3 equaling 12. The 30 can break down to be 2 times 15. 15 can break down to be 3 times 5. So now we have 2 times 3 times 5 equaling 30. So to find the greatest common factor of the 12 and the 30, we see what factors do they have in common. Well, they both have a 2 and a 3 in common. So the GCF for the number portion would be a 2 times a 3, which would be 6. But then we have to incorporate the variables in there as well. So we ask ourselves, what factors do the two numbers have in common, the two set of variables? So they both have an x squared in common. Looking at the x's, they both have an x squared in common. So we have x squared as part of my solution. And looking at the y's, they both have 3 y's in common. So they have y to the 3rd power in common. So the greatest common factor would be 6x squared y to the 3rd power. And for the LCM of the same set of monomials, I break down the 12 and the 30 as we already did. And the LCM of 12 and 30 would be same beginning, but now we're going to see what factors do we have represented. we have 2's, 3's, and 5's. So the question is, how many of each are we supposed to take? Well, the 2's, we see which one has the most 2's, and this one has the most with 2 2's. So we take 2 2's. Then we ask which one has the most 3's. Well, it's a tie, so we just take either, doesn't matter, but it's just 1, 3 is going to be the most. And then the 5's, this one has the most with just 1. So we have 1 5. So you multiply those together to get 4 times 3 to get 12. 12 times 5 is 60. Okay? And then looking at the variables, we do the same thought process and see which one has the most x's and which one has the most y's. Well, for the x's, this one has 2 x's. Over here we have 3 x's. Which one has the most? Well, it's going to be the one with 3. So we have 3 x's. And then which one has the most y's? This first one has 3 y's. The second one has 5 y's. So this one has the most with 5. So we take all 5 of its y's. And my solution would be 60, x to the third, y to the fifth power. And now one last thing is if you have negative numbers. So here we already did this one. We get 60x to the third, y to the fifth. But what if we have a negative 12x squared, y to the third? And this is going to be the same for LCM or GCF, where you basically just ignore the negative and make it a positive. So it's not going to, the LCM will not become a negative 60. It's still going to be a positive 60. So same concept, just ignore the negative for both LCM and the GCF. And that concludes our lesson for today. So we will see you next time.